All right, the next topic we're going to take a look at is called rigid transformations. And it says rigid transformations are ways to move an object while not changing its shape or size. So that's important. When we move a shape, we're not changing it. Specifically, they are translations. A translation slides an object horizontally side to side or vertically up and down, or both. Or it could be a reflection, a flip across a line called a line of reflection. So let's look at our shape here. The first shape we're starting with is A. So that's the main shape. And A was translated or moved, slid to the right and then up to get to the translation. Okay? A reflection means it was reflected, so it's a mirror image. And in this case, it was reflected across the x-axis. So it was literally flipped across the axis. It's the same distance away on both sides. Okay? And then a rotation means I rotated it. So we didn't read that one yet. A rotation turns an object about a point. To rotate an object, you must choose a point, direction, and angle of rotation. Okay, so remember that 90 degrees is one turn, and it could be clockwise, or it could be counterclockwise. Okay, so if we look at the shape A up here, it looks like it was rotated down 90 degrees. Okay, could I rotate it another 90 degrees? Yes. Okay, that another 90 degrees would take it down here. So what would it look like? Think about it. So you're rotating about a point. So what point stayed fixated? Okay. And then I could rotate it from here over here. Okay. We're not going to get too specific with the rotations, but we're going to take a look at a couple IXLs. The first IXL I'd like to look at is P1. Make sure you're in 8th grade. P1, line of symmetry. This one shouldn't take you very long at all. It says, is the dotted line a line of symmetry? So if I fold along that line, does it match up on both sides? Nope. Is the dotted line a line of symmetry? Yes, it will match up if I fold along that line. Okay, that's all you're doing for this one. That one should be pretty easy. You should get to a SMART score of 80 pretty quickly. Let's look at P2. This is rotational symmetry. It says, does this picture have rotational symmetry? So that means, could it be rotated and get the same image? No. Does this picture have rotational symmetry? Doesn't matter how I turn it, it's always still going to look like this slice of kiwi. So yes. Does this one have rotational symmetry? Yes, because most objects that are round, when you rotate them, they're going to be on top of each other again. Does this have rotational symmetry? No. If I turn this can, it's not going to be the same. Okay, that should be pretty easy as well. Let's look at P3. P3 says, this image has rotational symmetry. What is the smallest fraction of a full turn you need to rotate the image for it to look the same? Okay, so this shape is divided into thirds. Okay, here's a third, here's a third, and here's a third. So it has to be a third of a turn. This image has rotational symmetry. What is the smallest fraction of a full turn you need to rotate the image for it to look the same? So the smallest one is the key here. I'm going to draw some lines of symmetry. Okay. See what I'm doing? Okay. So how many spaces is that? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the smallest turn could be a 12th. Okay, so that's not an option. So could it be a 9th? I'm going to say no. I'm going to say it's going to be a 6th. Okay, so this has 1, 2, 3, 4, 5 stars, so it has to be a 5th of a turn. So this one says the smallest fraction, and remember that these lines would have to line up on top of each other. So if I rotated this ball 90 degrees, now this isn't going to be the best image. These lines would now be here. Okay? So it says the image has rotational symmetry. What's the smallest fraction of a full turn? You need to rotate the image for it to look the same. So it's going to have to be half of a full turn, because if I turn this image, another full turn. Okay? That one shouldn't be that hard either. The next one we're going to take a look at is translating P6. Translating. Remember, this is a slide. So it says graph the image of 6, 4 after it's translated 6 units up. So we're taking C and moving it 6 units up. Okay? Graph the image of -6, 3 after it's translated 5 units right. So we're going to the right. And you're just plotting the point. Okay? I'm not drawing with the drawing tool, I'm just plotting. This time we're going 8 right and up 1. I would always double check on these to make sure you're going the right way. So I think you can draw on this. Yeah, you can go over and then up. Okay. 1, whoops, let's put it back there. I was just double checking to make sure it was right after I moved it. 5 units right and 4 down. Puts me there. So that one shouldn't be too hard either. You're just sliding the point. Remember, translation means slide. The next one we're looking at is P8, reflecting over the X and Y axes. Okay, and it says reflect this over the X-axis. So where's your X-axis? It's here, okay? How many away from the X-axis is point H? 5, so that means it has to be 5 below. Okay, it's a reflection. Graph the image -1, 10 after it's reflected over the X-axis. So it's 10 away from the X-axis up there, and it'll be 10 away down here. We're reflecting over the Y-axis this time. So this time it's over 1, so now it'll be over 1 on this side. Okay, the whole image over the X-axis. Okay, so K is 1, 2, 3 away, so it'll be 3 away down here. L is 4 away. Okay, J was 3 away. Oops. Okay. Okay, so you have to get the right order there. So your double check is that it's the same distance away here that it is here. Graph the image after it's reflected across the x-axis. So the best way to do these is to count. So how many away is U? It's 7 over, so it's going to be 7 over on the other side. V is also 7, and it's 3 higher. Okay, and then W is going to be the furthest. It's way out here at -10. Nope, it's there. Okay. What? Oh, I went the wrong way. So be careful, make sure you read directions. I reflected across the Y and it asked me to reflect across the X. All right, we're reflecting across the X-axis this time. Okay, so double check that you're reading the directions. I make mistakes too. C is 6 away, so it'll be 6 away down here. And D is the same distance, okay? And then F and E are 10 away. I always do this wrong. Okay? Now we're right. That's all for rigid transformations. We looked at rotations, translations, and reflections.